Hello, this video is section 2.5, measures of position. In other words, seeing how a data value ranks in a list compared to other data values. The z-score sort of tells you that too, but this gives it to you in a more user-friendly manner, I think. So first thing we'll talk about is something called a percentile. Some people will know what this is, some don't. That's all right. If you don't know, you're about to learn right now. So a percentile means, like say for example, if you took some standardized test and it said your score was the 85th percentile. Now you might think that means you got 85% of the correct answers correct. That is certainly possible, but that's not what percentile means. It's a ranking. It means that 85% of the scores were lower than yours and 15% were above. And percentiles are used all over the place. For example, babies. You take maybe you take your baby in, 3-month checkup, oil change, tire rotation, the whole 9 yards, and they check your baby's weight and maybe check your baby's length. I guess they don't have height because at 3 months they're not going to be vertical yet. So they may tell you, okay, your baby's at 53rd percentile for height and 47th percentile for weight or something like that. And so obviously the weight, you might be concerned if it's within a certain percentile, but the doctor might be concerned, but not with 47 percentile. That means you're kind of right in the middle. And length probably not that important. Unless you're planning on having a child that's a professional basketball player. But so it's just that's what it's telling you when they give you these percentile results. Now here's one method of getting percentiles. We're going to be more interested in these things called quartiles, but let me just kind of show you this real quick. And there's kind of other ways too. This isn't the only way to do it, but I'll just kind of show you how this one works. Now percentiles, let's see if I have that written up here. Yes, the capital letter P with a subscript number. That's usually, and we'll see percentiles again later in chapter 5. So P sub something is a percentile. And like for example, look down here. See, I see P sub 40. It's hard to tell that's a subscript, but it is. P 73. Now let's look at this, how this method does it. Now this says you take your percentile, and over 100 means just means it's a decimal. So if it's 85th percentile, 85 over 100 is 0.85, and you multiply it by n, which is the number of values in the data set. Now let's talk about what this L is. And this says it's the next integer greater than that amount right there. So it rounds up, similar to finding class width on a frequency distribution. You round up, even if it's a whole number, you'd round up. If you come up with 8, you would round up to 9. Now what this L is, it doesn't mean the answer to your problem would be 9. It means it will be the 9th number in the list. So let's look at these two examples. So I'm telling you, I'm not even going to put this kind of question on a test or whatever, but I think it's worth taking a look at though, except for the core one. Let's see. 40th percentile for this data set right here, already sorted for us, 20 values. So you take 40 divided by 100, multiply it by 20, you get exactly 8. But L will be the next integer greater than 8. So if that would have been exactly 8, like it is, 8.2, 8.5, 8.7, we go to 9. L equals 9, and L means the number in the list, so it's the 9th number. You count your way down, 2, 3, 4, 5, 6, 7, 8, 9. Right there, there it is, the 14. That's your 9th number in order, sorted list. It's the 9th number, so the 40th percentile would be 14. Now here's an example, the 73rd percentile. You take 73 divided by 100 times 20, you get 14.6. That rounds up to 15. So L equals 15. That means it's going to be the 15th number in the list. So at the end of the row, you have 10. So there's no point in counting from the beginning. The start right there is 10, 11, 12, 13, 14, 15. There it is right there above that block, 28. And you see the answer is 28 here. Quartiles. Except the way we find these, we're not going to be using that method above. We have one called Q1, which is called the first quartile, which is the same thing as the 25th percentile. Q2, it's the second quartile, also known as the 50th percentile, and also known as something we've learned recently in another section earlier, it's the median. So the Q2 and the median are the exact same thing. And Q3 is the third quartile, 75th percentile. So it's breaking the data in quarters, essentially. So Q1 is the bottom 25%. Q1 to Q2 will be the next 25%. Q2 to Q3 will be another 25%. And then the Q3 to the maximum value represents the upper 25%. So we've got, I'll just put a little dot here. So that would be your minimum value right there at that dot, and then your maximum down here. And so if you're finding these manually, the way you actually do this is, and of course I'll show you the technology. But these aren't too bad, as long as the data sets aren't too large to do this from manual. You may, especially when I show you that Excel isn't very good for this, but you can still use the TI and do it that way. So, if you do it manually, you have to take your data list, as I have for this example 1, and then you have to sort it. Let's see, it must be working, you know, because like I say, these are all essentially median calculations, and that obviously requires sorted data. All right. Okay. So I sorted them. So here's what you do. Actually, you find Q2 first. That's the first thing you do is find Q2. So we don't go 1, 2, 3, we go with 2. And we're essentially breaking the data into 2 halves. So Q2, the median of this data set will be 9. And then what you do is you discard the 9 for figuring out Q1 and Q3. Whenever you have a single number value for your median, because remember you can either have one number or you can have 2 numbers in there that you have to average. But when it's one number, you just kind of, I got a block right over it. You don't deal with it. And I just put parentheses just for organizational purposes to make it look better. So you see I put a parentheses around a 1 and then the 8. So okay, there's my lower group. And then 9 to 17 would be my upper group. So you take this lower group and then you find the median of the lower group. That will be Q1. So you see here we go 1, 2, 3, 4, 5, 7, 8. The Q1 will be this single number right in the middle. That'll be 4. And then the median of the upper group, 9, 10, 11, 12, 12, 13, 17 will be that first 12 right there, so it'll be 12. Now I'll wait till we get to the homework to show you the actual calculator entry, but it's a command we've used before. It's the 1var stats. You enter your data in, and you scroll down. It's below where it shows the mean and standard deviations and all that, and you arrow down. And we actually have done this before to look at the median, but I didn't explain what all this other stuff is. But this gives you something called the 5-number summary, which is the min, Q1, median. Remember, median now is also Q2, so that's your Q2, Q3, 7, and the max. So you see, I'd enter those numbers in there, and it has Q1, median, Q3, has exactly what we have, what I have circled right there. But like I say, don't worry, I will show you this in action here in the homework. You just have to trust that I entered that in there correctly to get those answers, and I did. Now let's look at the next example. The next example has an even number of values. How many are there? 16. And remember, when you're doing a median and you have an even number of values, you average the middle two. So the Q2, the median, is going to be 7 plus 9 over 2 divided by 8. Now up here, when we had odd numbers, when you had one number, we threw it out. So you might be wondering, well, do I throw out both the middle two? No. When you're averaging middle two, what you do is the first one of the two belongs to the lower group, and the second one of the two belongs to the upper group. So that's kind of you might have thought they both were thrown out, but only when it's a single number median do you discount it when you're doing the other quartiles. So you look at the lower block. We also have an even number here in the lower block. We have 8 numbers. So it's the 4 and the 5 have to be averaged. So 4 plus 5 divided by 2 is 4.5. Up here, 10 and 11 are the middle two numbers of that group. They have to be averaged. 10 plus 11 divided by 2 is 10.5. So you have Q1 is 4.5, Q2 is 8, Q3 is 10.5, and here they are in the calculator. 4.5, 8, 10.5. The calculator is really beautiful for this. It's flawless. Here's another example. So this time we have a single number median. Q2 will be 6. And then so we separate, we throw out, so that 6 is gone. I'll just take that out of the way. And you look at the lower group, upper group. The lower group has 7. They both have the same amount, 7 numbers on each side. 7 numbers, and Q1 equals 4 will be the median of the lower group. And then 9 will be the median of the upper group, and that'll be your Q3. So it's 4, 6, and 9. Looks like I didn't put this one in the calculator, but it looks like I put the next one in the calculator. This example 4. So notice I haven't been using Excel yet, and I'm going to explain why here shortly. So here's another one. It's an even number of values. So you average the 6 and the 7, and you get 6.5. That means the 6 belongs with the lower group, the 7 belongs with the upper group. So in the lower group, you average the middle two. They're both 4s, so the average will be 4. The upper group, it's a 9 and a 10, makes 9.5. Come over here and we look at the calculator screen, and it's a beautiful result. It has Q1 is 4, median is 6.5, which is my Q2, and then Q3 9.5. It's wonderful. Here comes Excel. Excel's got 3 different quartile calculations. Now I've learned that the EXC and the X is supposed to be excludes the median, and then INC includes the median. But here's what I've come across without 100% proof, but every example I've tried. If you've got an odd number of values, this quartile.exe command seems to work okay. But the problem is, and I'll show you when it's even numbers, it's no good. I don't know what, I have no idea what it's doing. So, but let me, even then, I can't even prove it's always going to work for odd numbers, but it has for a couple of examples that I've tried. Now what data list this first one? The letters here represent that was column A. You see the functions using column A. That's the column I. So obviously evidently I had this data where that was in column I on the spreadsheet. So that's the reason I put those in there. And then down here, it looks like that was in an E, a column E. So this example, what am I saying? The first one is from example 1 up here. Yeah, you see that one, 17, 1, 9, blah, 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 blah. You see n equals 15. Odd number of values. Odd number of values. And the quartile command, A1, and you put the comma, then you put 1 means first quartile, 2 means second quartile, 3 means third quartile. And it worked. And this is just something I did. I highlighted those values like if we did it manually. I looked at it. Okay, 9's my deal, and then 4's the middle one of the first half. 12's the middle one of the second half. And you can always do these manually like I did up there if you want to, but it looks like it's going to be okay for odds, at least the ones I tried, but boy, I can't even prove that. I almost don't know if I'd even trust it. And this one, I'm not sure if this, did I mention if this was just, I think I said I made this one up. Yeah, I just made this data value up with an odd number of numbers. So once again, I identified 8 manually as my middle value, and you see there's 5 numbers above it. 4 is the middle of those 3, and then 13 is the middle of the bottom ones, and the quartile exe command worked. 4, 8, 13. Now, this may be harder to visualize vertically, you know, versus the way I was writing them sideways above. So, you know, you could write these sideways if you wanted to and look at them. But anyway, this has an even number of values, 16 values. And these are the middle 2, the 7 and the 9. You're going to average those, and you're going to get 8. That means the 7, so you see I got the block below the 8, 7 goes with the upper half. So if you count down that upper half, there are 8 numbers. So hopefully you can see that visually. So it's going to be the average of the 4 and the 5 right there above. See, that 7 counts. So the 4 and the 5, the average of those two means it's going to be 4.5. Now for the bottom, the 9 goes with the bottom. Obviously there's 8 numbers, got to be same both sides. So you come down here, 9, 9, 9, and then the 10 and the 11 would be the middle 2. You average those, you're going to get 10.5. Now you don't see the data here, but I entered these values in the calculator. Look at the results. 4.5, 8, 10.5. Perfect. That's exactly what we want. I used all 3 quartile. There's 3 quartile commands in there. I used all of them. The only one it got right was the median. You look at that. It did not get the 4.5 right for Q1. It did not get the 10.5 right for Q2. So I would not use this at all, the quartile command, for an even set of numbers. It may work in some instances, that's just it. But the fact that it didn't work for this one is enough to convince me it's not trustworthy. I would go either manually or the calculator. The calculator is perfect. So, you know, a lot of times we go through this course, and that's what I'm saying, you don't have to commit to one or the other when I show you both things. There are a lot of things that we'll do, you know, you'll see, oh, I like Excel better for that. For example, like variance, the last section, because you can just do the variance in one command versus the calculator only gives you the standard deviation, then you got to square it to get the variance. So you can pick and choose what you want to use. They're both are available to you. The calculator is perfect. I've never seen it mess up once. But maybe this works if you count your data and it's odd and you want to use these commands and get it. And well, you can try it. All it's going to do is tell you if it's wrong. You know, you just have to redo the problem. So you can try, if it's odd, you can try to go ahead and just use, because I can see the advantage of wanting to use this because you don't have to, you know, if you can dump the data in Excel from the MyStatLab problem and it's already there for you. So that would be an advantage. So you might, maybe if it's odd, you'll just kind of use these commands, but it's even, either do it manually or put it in the calculator. That's what I would suggest. And we'll take a look at that in the homework here shortly. Here's a command, a thing called interquartile range. It's a calculation, just Q3 minus Q1. And so it's so if you have Q1 and Q3 found correctly, you can't really mess this up. The only way you can really mess this up is if you don't have the quartile correct. All right. Anyway, so real simple. And I don't think I'm going to ask you this on a test. In fact, I know I'm not going to ask you this on a test, but we keep talking about outliers. This is this command can help you find an outlier. And I'll just show you this real quick, more like an FYI. Never hurts to learn a little bit here. And it doesn't take too long. That's good news too. This says if you take your Q1 and you subtract 1.5 times IQR, any number below that you would consider to be an outlier. if you take your third quartile and add 1.5 times IQR, any number above that would be considered an outlier. So let's look at this example. Okay, real easy. We don't need technology. Real easy to pick the quartiles here. 10, right in the middle, Q2. So Q1 will be 5, the middle of those three. 14, the middle of those three. So the IQR would be 14 minus 5, which will be 9. And I went ahead and did 1.5 times IQR. So 1.5 times 9 is 13.5. So if I take my Q1 and say 5 minus 13.5, I get negative 8.5. If I take my Q3, I'm just following these rules right up here. If I take 14 and I add 13.5, I get 27.5. So what we're saying here is, in this data set, any number below negative 8.5 we consider an outlier. Any number above 27.5 we consider an outlier. Well, look at this. We have a 30 here above the 27.5, so that would give us reason to consider 30 as an outlier. Now, we'll come down here. It looks like I just kind of changed the numbers around a little bit. So your IQR will be 24 minus 14, which is 10. 1.5 times 10 is 15. So you take your Q1, 14 minus 15, and get negative 1. You take Q3 plus 15 equals 39. So there's no number below negative 1. There's no number greater than 39. So you see this time. So you see also visually, you can see 30 is a lot closer to 14 than, to 24 than it is to 14. So this just, we would say no outliers here. Okay. All right. So that's just a little cute little way to come up with outliers. All right. Now let's talk about, and I just mentioned this earlier, what we call the 5-number summary. 5-number summary of a data set. That comes right out of the calculator. Or you can get it like this, manually if you want to. Min, Q1, Q2, Q3, and max. Now, the 5-number summary is also used to construct a new graph called a box and whisker plot. See, it's got a box in the middle, and it's got a couple of cute little kitty whiskers there on the outside. Now, the way to kind of draw this properly, but you're not going to have to worry. You're just going to be, recognizing which is the right answer. But what I would do if I was drawing this, is I didn't show you here, is I draw a straight line, the line in the middle first, all the way from the min to the max. And I put a dot at the min, a dot at the max, and the dot at each quartile. So this data set, Q1 is 5. You see I have a dot there. Q2 is 6.5. It's the average of 6 and 7. Dot there. And Q3 is the average of 7 and 8. So I have a dot there. It's roughly 7.5. And those 3 dots, you just draw a box around there. And you put a vertical line right there in the middle at Q2. So your box is between Q1 and Q3 with a line there at Q2. The calculator can graph these box and whiskers. I don't know what gives it the height, though. I'm not sure exactly what the height fact. Maybe that's the way you scale the y-axis, because there is no height on this graph. This isn't like a frequency distribution, when you're looking up the y-axis. So what I do is just for appearances, when I sketch it, is just, it looks better, I think. You don't want it against the axis, so I just move it a little bit above the axis. But this could have been higher, and it still would have been just as accurate. So there's no y value here. And like I was mentioning earlier about how the quartiles work, so 25% of your data is, between each section there. The min and Q1 has 25%. Q1, it doesn't matter if they don't have to all be the same size. That doesn't mean anything. So you got 25% here of your data, 25% here, and then 25% in there, 25% there, 25%. So if you were looking at a box and whisker plot and you saw like a really, really long whisker on either side, you've probably got you an outlier there. Obviously, you could check if it was an outlier, but long whisker means there could be an outlier there. That's really all there is to box and whisker plot. Looks like I did one here in the calculator. I'm not going to worry about plot. I just have all the, I'm not going to do that in the calculator when I go to the homework. I'm not going to do the box and whisker plot. Because once you have the 5-number summary, you're going to be able to pick the right answer. So you don't really have to look at it. So I entered these numbers in. And I stopped. Okay, I'm not, you see where it says L1 5 is 6. There, that's that number. So it's not like I'm at the top, at the bottom. I'm somewhere kind of in the middle of the data set. Yeah, that represents these numbers. Obviously, before that, I've got the 17, 1, 5, 3, and then I got 6, 10, 12, 8, 5, 9, 12. And then below, which what you can't see, is 4, 13. You have to scroll down, but 4, 13, 12, and 7. They're all in there. I did it manually. I won't go over that, but if you have any questions. But so 1 var stats, and I scroll down, and then you see it right there, just what I got right here. 4, 7, and 12. The min is 1, the max is 17. And I just used the calculator to graph it. That's not important. But just get the 5-number summary. I think there's a question in the homework on this. Don't think I'd put this on a test, but if you look at a box plot, you see if the box plot is sort of heavier on the low side. It's got a short whisker here, but a longer whisker there. And just like we did with, frequency histograms and things like that, you still look at it as being heavier to the left. More data on the lower side means skewed right. That one's pretty symmetric. And then if the data is heavier to the right, that's defined as skewed left. So it's pretty much similar to like a frequency histogram. One last thing in this section before we go to the homework is defining more specifically z-scores, and we talked about z-scores in the last section, but they are measures of position, being above or below. In fact, we use them in the last section to determine the better relative position. So they kind of, belong in the last section. They sort of belong in this section too. But to help you prepare for one of the homework problems, I wanted to include this here because the problem's in this section. And z-scores based on their values. Z-score anywhere between -2 and 2. If it's not between -2 and 2, meaning less than -2 or more than +2, we consider that to be unusual. And then this was not being asked in the homework, but I wanted to bring it back anyway. The idea that if it's outside of -3 to 3, we would consider that to be an outlier. So that's just good information to know also. But the unusual part is important for the assignment. So let's do that now. Let's move right into the homework. All right, so that concludes this. Let's come over to the homework. See what we can do here. And I'll just pop around and take a look, see what looks interesting. And okay, that looks like a reason. Only 6 problems here, but I'll look. Oh, actually, it does want us to identify outliers for this. So I think I will do this one. Now, how many well, I can look when I dump this in Excel, but obviously you can dump in Excel. Remember, you don't have to enter them in the calculator. They don't need to be sorted or anything like that. All right, come on up. There we go. Now you see cells 1 through 15. That means there's 15 values. Boy, I could take a chance on this and try it because it's 15. It may work. I'll put this in the calculator also just so you can see. Before I enter the answers, I'll do both. So I'll come over here and I'll stretch this column out. That's where I want to put the formula text command where you can see it. Yeah, I discovered that command about a year ago, and it's just been wonderful to be able to show students. I never knew that was a thing, and because usually we'd have to just look at it's so small when you look and see what you type up here on the command bar. It's hard to see, and this yeah, having that for students to see has just been wonderful. So now I'm going to do quartile. Well, especially to see it if they're in a classroom. You could probably not a big deal if you're just viewing this. I cannot type right now. .exc, range of values A1 colon A15, comma 1 means first quartile. And once again, I'm going to center these just because I like the way it looks. I'll shrink this in a little bit. Oh, I don't want this. I grabbed the wrong one. Why is it grabbing both of these? I guess somehow I'm selecting both of them at once. All right, there we go. So this one I'll do quartile. Why can't I get my fingers in the right position here on the keyboard? It's probably good that I'm not teaching a typing class. Number 2, quartile, median. There we go. And you know what? You could have actually gotten that command just by doing the median. That would work also. That we saw earlier, the median command, because that Q2 is the median. And then, so now we need but before I commit to this, I'm going to do it in the calculator. So with those data, I think I'll be able to do it quicker. Yeah, anytime I can look at it, not have to toggle back and forth, to look at a screen and get the numbers, that always takes me longer because I can't memorize as many. My memory is not as good. Stat, edit. Okay, to clear the list, go up here, hit clear. Nothing happens. Scroll down, and there they go. That's weird to me. So here we go. Put them in there. So hope I get them right here. This is harder for me to do using a mouse pad than I prefer to have the calculator in my hand with the buttons. 57, 57. See, sorting is unnecessary. Sorting is only necessary if you were doing this like as a manual process, like I was showing by hand, like I was showing you in the notes. But for the technology, sorting is not required. 61, 60. So as long as I don't type this wrong, it will give us the right answers. Got them. So there's 16 values there. So I'll go second quit to get out of this. I go stat, calc, 1var stats. They're in L1. That's good. Got to scroll down to get to the quartiles. So you see Q1, 57, median 60. Q3 is 62. That agrees with what we got in Excel. Like I said, I think it's okay if it's an odd number of values. But like I said, it all depends on if you don't mind typing. You're not going to have like 500 numbers to type in there. It's never going to be that long. So, or you can just say, heck with this, I'm going to do it in the calculator every time. I'm not going to worry about whether it's even or not odd. I'm just going to type them in. Yeah, that would work. If you don't worry about if they're even or odd, you can put them right in the calculator and it's going to work every time. As long as the numbers are in there properly, of course. 57. But that was a good exercise. I'm glad we did, If we have an even one, we do. I'm not even going to put it in Excel. You could, we could call, as they call that in books, exercise left for the reader. I'm not going to go through all that. I will only use the calculator if it's even, or I'd rather do it manually if it's even, really, because that's easy enough to me. Interquartile range, well, you don't have to do this in your head, but I'm not going to insult your intelligence and put this in a calculator, but 62 minus 57, but you're not insulting your own intelligence by any means, but I'm not going to, yeah, 62 minus 57, use a calculator, that's 5. Look at us go. Now, outliers, I'm going to come over here and do the thing where I take I'm going to take the Q1, which I'll just type it in there as 57, minus 1.5 times 5 that we just got for the IQR. Then I'm going to go equals Q3, which is 62, plus 1.5 times 5. So like I said, I don't generally put this on a test, but it looks like we did need this to check this answer. Or if you just want to take your chances and just eyeball it and see if there's... I'm going to sort these now. Now I want to sort them because I'm looking for... We didn't need it before, as you saw, but I want to look for outliers. Data, sort. 49.5. Well, there's nothing below 49.5, but 69.5. Yeah, we got one above 69.5, don't we? So I'm going to call that fella right there 76. I'm going to call that fella an outlier. Obviously, the answer, if there was none, you just pick none. I'm going to go, I guess they're allowing for the possibility of more than one. So if there's more than one, you just comma separate each answer. Look at us. We are too cool. We are that talented. Oh, okay. I'm going to skip this one. This one's easy. You just look at the x-axis and fill out the 5-number summary. There, right, see everything's labeled right there. Super easy. I think this is one we'll have a box and whisker plot. Now let's download the data. Ooh, okay, good. I'm glad. This I am going to sort this because when we're looking at, well, actually we don't need to for the 5-number summary. We don't need to. I won't worry about sorting it. But you know what? 20 numbers, even, I'm not using that Excel command. So the choice is manual or calculator. When I say manual, I think you know what I mean, but I'll show you anyway. If you're not sure what I mean by that, it means, you know, doing them the way these examples were done, pretend like without the calculator there. That's what I mean by manual. Okay, I figured you knew that, but didn't hurt to say it. So, what? I lost my spreadsheet. I guess it's this one. It should be the most recent one. Yeah, 20 numbers. I'm not worried about sorting them. I'm going straight in the calculator. I'm not even going to take any chances with this. So we're going to go stat, edit, list. Now, since we just put these numbers in, there were like 15 of them. Anytime you can clear the list if you don't want to. Yeah, I guess I could clear it, but I just want to let you know that if you know you're going to be typing in more numbers than were already there, you can just type right over it. Of course, by the time I said all that stuff, I could have just gone up here and cleared it. So anyway, but I just wanted you to know that. So 4, 8, 8, 6, 2, 9. I'm going to have to scroll down a little bit. I'll put 4, 6. Let me zoom back out a little bit so I can get all of them on the screen at once there. And I'd like to zoom in a little more there. There we go. That way I can see all, it was kind of cutting off at the bottom. 629, so now I'm at the 7th value, which is right here, be 8. 7, 9, 5, 2, 6, 2, 9, 8, 7, 7, 9. And I'm not even close here. I'm missing, there's 20 values and I only have 18 of them in there. The good news is I don't have to insert them in order. I can put them, if I find them, I can put them at the end. $488. God, I wish this calculator here won't get any bigger for me. Yeah, see. 488 6 2 9 8 7 is 8. There's a 7 9. I skipped a 6 and a 9, number 10 and 11. Let's see if the next one. So there's 5, which right here, but I have it at 10. 5, 2, yeah. Somehow I missed these two right here, 10, 11, 6, and 9. Like I said, the good news is just stick them at the end. Oh, dang it. It tipped me back. I'm going to slow down or kick you back to the top. Okay. So thankfully the order didn't matter. Second, quit. Stat. Calc. 1 bar stats. Calculate. And I'll just kind of snip this out and put it on the screen. Like I say, if you're, let's see. All right, snip that out. Just put it right over here. Just look at it right there. So let's see what it's asking. Probably asking the 5-number summary, I'm sure. 2. Yeah, I think it was 5.5, but let me just double check. Try to remember it. Memorize it. 5.5, 7, 8.5, and 9. All right. 7. 8.5. And 9. So if you get the numbers entered in the calculator properly, which I didn't at first, but correct, I saw the problem and fixed it. But I was going to say, this works perfectly as long as the right numbers are in there. So, the human element here, right? Okay, so like I say, you can zoom on. These got little zoom buttons if you need to click on them to see where they are. Sometimes you can kind of eliminate answers. For example, well, there's only one answer this can be, but you can look to we can look to the rest of them, and I'll show you that it's right. Also, they all the only dot, the minimum. I figured they would have 2 of them with the right answer just to separate them, but the dot on the box and whisker plot has to start at 2 for the minimum value. None of the other ones start at 2, so it has to be A. But we'll go ahead and look. Just pretend like there was another one that started at 2. So that first quartile is right between 5 and 6. There's your 5.5. Your vertical line here in the middle, that's right at 7 for your Q2. The edge of the box right here is 8.5, and then just barely past that is your maximum value right at 9. So like I said, we didn't really need the calculator technology to sketch this. We just needed the calculator to get us what we needed. So let me see if there's any of these worth doing here. You can use what I'll let you do this one, but use what I had right there at the end of the notes. I'll let you figure that one there right there. Use this to figure that out. I'll let you have fun with that. But I think we pretty much have what we need as far. Okay, let's take a look at this problem involving z-scores to see what might be unusual or anything like that. Now, what do we have here? Calculating 2 z-scores. So for best actor, we have a mean of age of 43.8 with a standard deviation 8.7. And for supporting actor, age 54, but then we have the mean supporting actors age 50, standard deviation 13.5. So we have to conduct the z-score for Paul Newman at age 62. So it'll be 62 minus 43.8 divided by 8.7. I'll clear that. I'm going to use a little trick here I learned not too long ago. I can just use parentheses, but I'll put it this way. Alpha y equal like this, and I'll make it already a fraction. If not, this way I don't have to use parentheses. Otherwise, I'll show you the other way. But if you just kind of do it sideways, you'd have to use parentheses, sideways not being as a fraction. 8.7. Yes, let me just show you the other way. So you have to have parentheses there. There you go. All right, let's check the number of decimal places that it wants. It can be very picky. So I'm going to put in 2.09. Now the next one for best supporting actor, age 54. So we go alpha y equals, I'll do it that way again. Enter. So it'll be age 54 minus 50.2. I don't need parentheses doing it this way. And that standard deviation is 13.5. Two decimal places, 0.28 or 0.28. Either way is fine. Let's see how we did. Fantastic. Age of Paul Newman. More than 2 standard deviations. 2.09. Positive, so it means positive. 2.09 means above, which is unusual. Remember we saw the definition, unusual, anything outside of -2 to 2 is unusual. So more than 2 or less than -2 is unusual. Jason Robards, less than 1 standard deviation, above because it's positive, and that would not be unusual. It's not unusual. Terrific. And that's going to conclude our video for this section 2.5, measures of position.